Do you hear me if I speak up?
Yes.
Okay, so welcome to this presentation. I'm David and this is Umar, and we're going to tell you the story of how us and 8 students have, during the past 9 months, built the world's first e-foiling simulator. So to get started, what is e-foiling? Well, an e-foil is just a surfboard with an electric motor and a wing attached to it. That's the basics. And what this allows for is that with a handheld speed controller, the user can adjust the speed freely, and at higher speeds, the wing below it allows the board to elevate above the water surface and give the sensation of flying above the water. The first hydrofoil surfboard, or e-foil as we call it, was developed actually here at KDH by our stakeholder, Professor Jacob Kuttenkeuler, who is with us today, and a group of students. And since then, e-foiling has become a niche, difficult and expensive water sport. Buying one will set you back around 150,000 crowns, and renting is a few thousand per hour. So it's also, in combination, a sport which has an incredibly steep learning curve. Being able to surf like this, freely and standing up, will take 10, maybe 20, maybe 100 tries, and between each try you will have fallen off, hit the water, hopefully not injured yourself, and you have to swim back. So this is kind of a difficult process, and with this background in mind, Professor Kuttenkeuler approached us and gave us the task to develop an e-foil simulator which mimics foiling in the water as closely as possible. The aim of this is, of course, then that one could learn foiling basics on the simulator, and when going into the water, one would have the movement down and could start foiling right away. So from the start of the project, some components were predetermined. For example, the visuals, visualizing the waves and the board and the environment, should be provided by a virtual reality headset of model Meta Quest 2 that is sitting on the user during use. For simulating the physical movement of how the board moves in the water in real life, a machine called a Stewart platform should be used. This is something which costs around 500,000 crowns, but was in possession of KDH prior to the project. And this was also a key component which allowed the project to happen. Lastly, for calculating how the board moves in the water, based on how the person is standing on it and how he's using the gas pedal, a simulation model which was developed by the stakeholder himself prior to the project would be used. It would then be in charge of all the calculations on the board. So what was left for us to do? You might wonder then. Well, one of the main things was to build a force-sensing surfboard which the user could stand on and which would then transmit this weight distribution if the user is leaning left or right or backwards and forwards to the simulation program for calculations. As well as this, we needed to create a virtual reality environment which simulates a visual simulation of the simulation of the waves, the board, everything. Finally, and this is really the main challenge of the project, it is to integrate all these different components into a fully functional simulator which feels like one experience.
So, the final system design consists of 3 main subsystems and a handheld speed controller. Let's begin by looking at the system from the left and work ourselves all the way to the right. On the left we have the force sensing board and we have the handheld speed controller. Force sensing board inputs the weight distribution of the rider, and the handheld speed controller inputs the throttle of this controller. The simulation program takes these inputs and calculates the board movement. It then sends them forward to the Stewart platform and the VR headset. It does this about 200 times per second. So let's talk about the board for a bit. Subsystem 1. The base of the board is mounted on the Stewart platform. Then the frame is mounted on the base of the board, alongside with the force measuring sensors. Then the built or assembled surfboard that you can see in the picture is contained by the frame. Now we have a platform that the user can stand on, and we have the force sensors measuring the rider's weight input. So we can calculate the forwards, backwards, left, and right weight distribution. Additionally, we added a LED strip indicating the weight distribution, as you can see in this video. This is very useful for instant feedback to the group and also looks a bit pleasing. Subsystem 2, the VR environment. The purpose of this subsystem is to really immerse the rider into the simulation and also give them the best experience possible in a real-life scenario. This world was not created by us, but by a contact of the stakeholder. However, in order to make it work, we had to modify it to suit our needs. And by doing that, we added some surfing sounds and some islands in order to make the frame of reference for the rider better. We've also added other stuff that you will get to experience during the demo.
So finally, we have the last part of the system, which is the simulation program. And this is really the heart of the entire simulation, as it takes in the loads from the force sensing board of how the person is standing on the board, and uses this information to calculate how the board should move, and then send this to the physical steering platform and the virtual environment in the VR headset. This program was developed by the stakeholder prior, as I mentioned, but to make it functional and work with the simulator environment, we had to add a lot of functionalities during the project, such as communication with the VR headset and the steering platform, and many other things that the interested of you can ask about later on the presentation, on the demo. So, with everything put in place, the result of this project is a proof of concept that the technologies used and the methods used in this project are not only viable to make the world's first e-foil simulator, but they're also viable to make a simulator which accurately recreates the foiling sensation of an actual board. Thank you.
We head over to engineering side to look at the demos.
Hur vet jag om jag foilar? Är jag uppe? Det är svårare än det är. Tack! Det är svårare än det är. Det är svårare än det är.
Vilken dag att fylla år på!
Ja. Självaste simulatordagen. Woho!